There is a ghost in the machine right now.
Oh, absolutely.
As you listen to this, tens of thousands of people are using a massive, unannounced AI upgrade. It's hidden deep inside their standard accounts. And, well, the strangest part, OpenAI isn't saying a single word about it.
They're completely silent. Which is, I mean, it's wild because we're tracking an absolute flood of leaked data surrounding what the community is calling GPT 5.6 Pro. And today, our mission is to basically cut through that noise.
Right. Welcome to the deep dive. We aren't just going to list off rumors today. We are going to trace the exact mechanism of this stealth rollout.
Yeah, we're going to dissect how this hidden model is suddenly generating entire playable 3D worlds from just a single prompt.
And ultimately, we are asking the defining question of this new AI era. OpenAI might have solved raw mathematical logic, but can they finally teach an AI to have actual taste?
Exactly. But before we look at the mind-bending stuff this model is building, we really need to understand the delivery mechanism. Because if you open your dashboard today, you will not see a GPT 5.6 Pro button anywhere. You just see the standard lineup.
You see GPT 5.5, 5.4, 5.3, and the O3 models. There is no beta banner. There is no splashy announcement.
Right, nothing.
But savvy developers started noticing a distinct pattern. If you select the standard GPT 5.5 model and you toggle the intelligence slider up to high, something weird happens.
Right, because normally it just gives you a slightly more thorough answer.
Yeah, exactly. But suddenly the behavior diverges. Most of the time, it is business as usual, but occasionally the prompt just hangs. The generation time stretches out significantly.
Oh yeah, it takes way longer.
And when the output finally lands, it is operating on a completely different level of logical sharpness.
It is a classic A/B testing strategy. They are quietly routing a small percentage of live traffic to an unannounced checkpoint.
And this quiet testing phase has ignited a massive speculative fire.
Oh, completely. On Polymarket, which is, a platform where people place real money bets on real-world events, traders have wagered over $1.1 million.
Wow.
Yeah, 1.1 million betting that OpenAI will officially launch this model between June 22nd and June 28th.
That is a very specific window.
It is, which raises an interesting point about how these betting markets operate.
Yeah.
People aren't just throwing $1 million at a random hunch.
Right.
These traders are watching global server load spikes. They are monitoring brief structural leaks, like when a candidate checkpoint accidentally appeared on the Design Arena platform before getting hastily scrubbed.
Nah, I remember that.
Yeah, and they even track OpenAI's historical release cadence. That cadence has actually compressed to roughly a 7-week cycle between major updates. Late June aligns perfectly with that math.
I have to pause there because that stealth nature feels almost counterintuitive from a traditional software perspective.
How so?
Well, why test a flagship model so quietly? It's like ordering your standard daily coffee, but occasionally the barista slips you an experimental nitro cold brew just to see if your heart rate spikes.
That is exactly what they're doing.
If they ask your opinion, you overthink it. But if they just watch from the kitchen to see if you finish the cup faster, they get pure, untainted data on the formula.
Exactly.
So why the unlabeled gap? Why not just call it a beta test and get deliberate user feedback?
Because deliberate feedback is inherently biased. The moment you slap a beta or GPT 5.6 Pro label on the interface, you introduce the observer effect.
People act differently.
Yes. Users immediately change their behavior. They try to break the model, they feed it impossible logic riddles, or try to bypass its safety filters just to see what happens.
Right, they stop using it for normal work.
Precisely. By running a blind A/B test, OpenAI captures how the model handles mundane, everyday tasks. Drafting a basic email, summarizing a boring PDF. That baseline data is the ultimate ground truth before a public launch.
Testing the waters quietly to get raw data before the official splash.
You nailed it. That's exactly the strategy.
Okay, so we know they're quietly serving this nitro cold brew to a fraction of users. What happens when those users ask it to actually build something complex?
Oh, this is where it gets crazy.
Because the leaked demos aren't your standard text summaries.
Not even close.
Yeah.
We are talking about fully interactive, playable environments. And the critical detail here is the architecture.
Right.
These environments are running in single files generated from a single prompt.
A single prompt. Wow. Let's dive into the voxel and rocket scene. This is a complete 3D house, and it is generated entirely inside one HTML file using WebGL2.
Yeah.
And for anyone unfamiliar, WebGL2 is a tool for rendering 3D graphics directly inside your web browser.
And what makes this specific voxel scene a breakthrough is its structural coherence. In previous AI models, one-shot 3D generation suffered from terrible object permanence.
Right, it would just fall apart.
Exactly. The moment you rotated the digital camera, the illusion shattered. The back of the house wouldn't exist, or the geometry would collapse into a mess of intersecting polygons.
But with this hidden checkpoint, the structure actually holds. The architectural proportions remain mathematically sound. You can actually walk through the generated scene live.
It's wild. And they didn't stop at simple houses either.
No, they didn't. Testers built a Boeing 747 using 3.js, which is a popular 3D coding library.
The spatial reasoning required to write code for a 747 is immense.
It is. The AI isn't just painting a flat picture of an airplane. It has to deeply understand z-depth, aerodynamics, and structural spatial relationships.
They also fed prompts into Blender, the professional 3D modeling software. And the AI generated a robot scene where the lighting and materials look like a painstakingly finished studio render.
But here's where it gets really interesting. The crown jewel of this leak isn't a static 3D model.
No, it's not.
It is a functioning simulation game built in one HTML file in 48 minutes.
The sim-style game is a phenomenal benchmark. It has working character movement. It has branching dialogue.
Yeah.
It actively tracks the state of the digital world over time. It is wiring together an entire game loop, game physics, and user interface logic without a single human developer touching the code.
Whoa. I mean, imagine generating an entire functioning simulation game, complete with physics, in a single file in 48 minutes.
It really is hard to wrap your head around.
The leap in context window management there is staggering. To hold the logic of a game state for nearly an hour without forgetting the rules it established in minute one, well, that is a massive engineering feat.
It is a monumental technical achievement. But there is a glaring catch that all the early testers keep highlighting.
Ah, the catch.
Yeah. While the underlying math, the structural code, and the physics are highly believable, the overall polish still trails behind Fable 5.
Fable 5 being the current reigning champion among rival AI models for purely creative tasks.
Exactly. When you look at the 5.6 Pro outputs, they feel a bit robotic. They completely lack true creative taste.
That is such a fascinating distinction. If this hidden checkpoint perfectly nails the complex structural logic and the physics, why does it still feel robotic compared to Fable 5?
Well, if we connect this to the bigger picture, it illustrates the deep divide between organizing complexity and possessing an aesthetic soul. Like 5.6 Pro is a master architect. It can wire up a game loop flawlessly.
Yeah.
But Fable 5 understands visual nuance. Fable 5 understands how light should feel in a room to evoke a specific mood.
I see.
GPT 5.6 Pro is solving the math of the scene. Fable 5 is solving the art of the scene.
Great at drawing the blueprints, but still missing that human artistic soul.
That is the perfect way to look at it.
Which naturally makes me wonder about its performance in a purely 2D space.
Right.
If it has perfect blueprints but no interior designer in complex 3D environments, what happens when it tries to design a flat 2D website? How does it stack up against its direct predecessor, GPT 5.5?
So the community actually ran a brilliant direct comparison to test exactly that. They used a highly detailed spaceship design prompt, and the results exposed a major paradox.
Okay.
GPT 5.6 Pro generated the image, but it ran for 87 minutes.
Wait, 87 minutes for one single visual prompt?
Yep, 87 minutes of continuous generation time. To put that in perspective, the older GPT 5.5 model, running on extra high intelligence, completed the exact same prompt in 34 minutes and 42 seconds.
I really have to point out the paradox there. An 87-minute runtime isn't a feature you put on a marketing brochure.
Definitely not.
That represents a massive, almost unsustainable computing cost. If an AI takes an hour and a half to think through a visual prompt, the sheer volume of GPU cycles burning in the background is staggering. How do you scale an API that takes 87 minutes to answer one user?
You don't. At least not yet. This massive resource burn is likely why it is hidden behind the A/B test rather than rolled out to everyone.
That makes sense.
But we have to look at what that 87 minutes actually bought them. 5.6 Pro definitely won on the micro details, the specific lighting, the metallic shading on the spaceship, the intricate detail on the captain's chairs, and the exterior hull.
Okay.
It also produced far fewer visual glitches or warped pixels.
But it wasn't a clean sweep.
Right.
GPT 5.5 actually produced better interior rooms and far more compelling planets in the background. And again, the rival model, Fable 5, still beat both of OpenAI's models on the overall cohesiveness of the spaceship design. It really sounds like 5.6 Pro is just an incremental update here, not the Fable 5 killer everyone was hoping for.
For raw blank canvas creative design, yes,
Yeah.
it is purely incremental.
Right.
But the testers uncovered a completely different strength when they moved to design mimicry. They handed 5.6 Pro a single reference image of an existing e-commerce landing page, and the model recreated it flawlessly. It nailed the grid layout, the typography, the exact stylistic vibe of the original reference.
I have to admit, I still wrestle with getting AI to match a specific design template. The prompt drift is real.
Oh, it really is.
You ask for a minimalist blue button, and 3 prompts later, the AI has decided your whole website should be neon purple. So seeing a model lock onto a visual template and hold it perfectly is genuinely impressive.
It's huge for front-end developers.
But does its success with the e-commerce page mean its true strength is just mimicry?
This raises a critical question about the future utility of these models. Right now, its absolute superpower in the 2D visual space is strict replication.
Okay.
It performs exponentially better when you provide rigid guardrails and clear visual references. When you ask it to create from a pure blank page, it struggles to make cohesive, stylistic choices. It needs you to define the aesthetic boundaries first.
Better at strictly following the instructions than inventing a brilliant design from scratch.
That is the reality of its current architecture, yeah.
We will be right back after a quick word from our sponsor.
Stick around.
All right, and we are back. So, we have established that this model needs strict instructions to design a standard website. But there is one highly specific visual format where it doesn't need to mimic. A format where it is genuinely shocking the developer community.
SVG generation. This is the undisputed, hidden superpower of the leaked checkpoint.
Just to define that for a moment, SVG stands for Scalable Vector Graphics. Simply put, it means scalable images drawn using mathematical formulas instead of individual pixels.
Exactly. And because they are entirely mathematical formulas, generating complex lighting or shading is incredibly difficult.
Right.
When an AI draws a normal JPEG, it's basically just placing a dark pixel next to a light pixel based on training data. But with an SVG, the AI has to write pages of raw code to define gradients, light sources, and geometry.
And the demo that broke the internet here was a BMW M4CS.
Yes. 5.6 Pro rendered an SVG of this car, featuring metallic shading, correct lighting reflections, and flawless perspective.
Amazing.
It looked astonishingly close to a photograph, purely driven by math. They ran a direct head-to-head comparison against Fable 5. They pushed Fable 5 across its low, medium, high, and extra high thinking levels.
And what happened?
Fable 5 failed entirely. It could only produce flat, cartoonish vector styles. It simply couldn't do the high-level metallic math.
That is a definitive victory. And it wasn't just a car. Another tester prompted it to generate a Windows 11 interface.
Oh, this one was crazy.
It recreated the full operating system UI in SVG format. The file explorer, the taskbar, the calculator app, all mathematically drawn. It cleanly outclassed another specialized model called Mythos.
It did.
But, as always with this checkpoint, there was a strange downside.
There always is. It hallucinates extra interface elements. During the Windows 11 generation, it added bizarre, unnecessary pop-ups and lines of text that simply do not exist in the real operating system.
It's like an overly eager intern who gives you the pristine, incredibly complex spreadsheet you asked for, but then decides to add 10 confusing pie charts that you didn't need just to prove they could.
Yeah.
Why does a model this mathematically advanced throw in fake pop-ups and random text?
Because the model is heavily optimizing for extreme detail. It equates visual density with quality.
Oh, I see.
It has all this incredible processing power and structural understanding, but it completely lacks editorial restraint. It doesn't know when a design is actually finished and should just be left alone.
Incredible attention to detail, but severely lacking in editor's restraint.
It just wants to keep painting until the canvas is entirely full.
So bringing all these bizarre technical quirks, the massive 87-minute generation times, and these undeniable SVG superpowers together, where does this leave us in the broader AI arms race?
Well, if we look at the honest benchmark comparison, 5.6 Pro absolutely dominates on SVGs. It dominates on vision replication. And it wins heavily on deep game logic and code stability.
Okay.
But it still trails Fable 5, as well as Claude, another major competitor, on standard front-end web generation and overall aesthetic polish. We should also caveat that Opus, another heavyweight model in the industry, wasn't benchmarked in this specific leak.
And then there are the rumors floating around the edges of the technical data, the unconfirmed market noise.
Pricing is a huge topic of speculation. The rumor mill strongly suggests the cost will sit somewhere right between Fable 5 and Opus 4.8, while magically matching the price of the older GPT 5.5 model. But the code name confusion is where the data gets incredibly muddy. Testers are tracking an entire constellation of names. You've got Iris Alpha, Ember Alpha, Beacon Alpha, Kepler, and Kindle.
And strangely, some testers are reporting that the checkpoint named Kindle Alpha actually performs worse than the one named Kepler.
Yeah.
Yet Kindle is supposedly the finalized release candidate. I really have to push back on the logic of that specific rumor. If Kindle Alpha is verifiably performing worse in testing, why on earth would a multi-billion-dollar company make that the flagship release candidate?
Doesn't make sense.
It really highlights how messy and contradictory these secondhand leaks really are. We have to treat the code names with extreme skepticism.
The code names are a distraction, honestly. The underlying behavioral shift is the only thing that actually matters here.
So zooming out and looking at the landscape today, is this hidden checkpoint the Fable 5 killer the industry has been waiting for?
Not entirely. It is closing the technical gap at a terrifying speed, especially regarding structural logic and complex SVG math, but it is absolutely not taking the creative crown across the board.
Closing the distance fast, but definitely not taking the crown just yet.
Exactly.
So what does this all mean? Let's synthesize everything we've unpacked today. The overarching theme is that we are witnessing a live, highly quiet evolution of artificial intelligence happening right inside our daily tools.
Yeah.
The sheer fact that OpenAI can run this massive A/B test on live accounts without a single announcement shows how fluid and continuous this technology has become.
And the specific capabilities of GPT 5.6 Pro prove that a major historical milestone has been reached. Complex logic, deep physics, structural object permanence,
Yes.
building a one-shot HTML game that maintains state tracking for 48 minutes. These are no longer theoretical challenges. These are now solved problems for AI.
The structural foundation is built, which means the new ultimate frontier for artificial intelligence isn't just raw computational capability anymore. It is taste. It is editorial restraint. It is knowing how to make a digital environment feel distinctly human rather than just functionally correct.
It is the classic difference between building a house and creating a home. The AI can build the house perfectly now, but making it feel lived in, that is the next great technological leap.
I highly encourage you to check your own dashboard. Switch your model over to GPT 5.5. Set your intelligence slider to high. See if you can spot the slower, significantly sharper responses of that ghost checkpoint for yourself. Experience that untainted A/B test firsthand.
It's definitely worth trying.
I want to leave you with a lingering thought to chew on. We talked about that ghost in the machine. If an AI can now quietly build complete physics-based 3D world and functional simulation games in a single file, just by us asking, what happens to the value of human coding when that ghost finally develops real taste?
That is the million-dollar question.
Until next time, keep diving deep.